In this section, we're going to start making things more real now, and we're going to start bringing the REST, or representational state transfer fundamentals, into the picture on top of the HTTP things we've already discussed. So REST is an architectural style that has very broad reach. It emphasizes features such as scalability, generality, independent deployment, reduced latency via caching, security, and encapsulating legacy systems. Many services balance a truly RESTful API with a positive developer experience. So in other words, most APIs are not truly or fully RESTful. They are RESTful-ish, and we try to balance that with a positive developer experience. When you're thinking about REST, you define your service's resources and are typically as a collection of items, like users. And that would be a collection of users. And then you put a Jeff user in there, or a Aiden user in there, or a Grant user in there, and those would be the items within the collection. These resources are state, so think in terms of nouns, right? These are things like a user is a noun. Do not think in terms of behavior. With REST, the general behaviors are create, update, get, and delete. Your standard CRUD operations, create, read, update, and delete, are your typical behaviors that you put on top of these resources. And determine your hierarchical URL paths to expose your resources. So spending time on what your URL looks like to expose these resources is a critical thing that you really should be investing a lot of time in. Partially because URLs to resources identify that resource. It's a way to get to it. It's a locator. And the URL should be stable over time. That is, a customer might use our URL to create a resource today, and then 100 years from now, that URL should be usable in order to go and read that resource back. So the URLs are typically stable over long periods of time. And it's important to consider that. So let's take a look at an example. So to do the standard CRUD-like operations, you might create a REST path that looks something like this. So after the HTTP scheme, : / and then the host name, then we have a slash and the rest of the URL path. So we might have something like /song management. Song management is the name of a document that contains the resources. Sometimes this is omitted and the actual host name, that is the name of the service, represents the document itself. After the document, if you have it, is then typically a collection name. So this service is exposing a bunch of users. Users is a collection resource. It holds a bunch of items. Of course, those would be the individual users. When you are naming this collection, we suggest you use plural, so it's users plural, for example. URLs, we recommend lowercase for almost all things. And again, it should be a noun, right? Users is a noun. We also recommend that within your URL, you avoid having more than 2 collections. That makes the URL long, harder for people to follow. In this URL, we have 2 collections. There's users, and then you would have an ID of a particular user, and then that user might have multiple playlist collections under that. Or it's a playlists collection, and then within the playlist, there might be playlist IDs for each of the individual playlists that a user might have. So users and playlists are 2 collections, and they're in a hierarchy. So you go to the users collection to talk about a specific user identified by an ID. Then for that user, the playlist collection, and then under that, a playlist ID to indicate a particular playlist for that particular user. So now we have the item resources, which have IDs to represent them, and you'll use, request and response body will hold the item state here. To create a user, you would typically use patch, RFC 5789, with a JSON merge patch request body. And this will go and create the user of the ID that the client specifies on the service. And then the JSON merge patch is the JSON that indicates all the properties that you are setting for that user. Patch is used to do a create. It's also used to do an update. So let's say you create the user and you need to update their phone number or their email address. So then you would also use patch. So patch is useful for create and it's useful for update. Patch also works very well in versioning scenarios, which I'll be talking more about very shortly. If you want to offer create and a wholesale replacement, that is, you want to replace the entity or the resource in its entirety, then you can use put with a JSON payload. But you have to be aware of versioning issues here. Let me briefly explain. So let's say that in version 1 of your service, you have the person's name and their phone number. And so a client who knows about version 1 of the service will only ever go and set the name and the phone number. Let's say in version 2 of the service, you now add an email address as a new property on the resource. Well, if the V1 client does a put operation, it doesn't know about the email address. And so if the email address was set by a V2 client, the V1 client, when it does a put, it will erase what was there. It'll erase the email address. And that causes state to vanish. Patch, as you'll see momentarily, because I have an animated slide that I'll walk through, patch solves this versioning issue. So it's highly recommended you use patch whenever possible, even over put. Read operations would be done with a get, and then of course it'll return a JSON representation of the resource in the body, response body. And then delete, you would of course use delete. And as I said earlier in the course, all these operations must be implemented idempotently on the service. So now let's walk through this animated slide so we can see how all these pieces fit together. In the top left corner, I show a collection resource that is managed by the service. This is a collection of airports and information about airports. So first, each record in the database or in the collection is going to have a field which starts with the airport code. That's actually the key into the database, so we can look up an airport by way of its airport code. Then there's another field in here, which is the creation date that indicates when this airport was added into the collection. And once that's set, it's read-only after that. Then we also have for each airport the number of runways that are available at that airport. And then we finally have the number of takeoffs per hour is another field that we maintain for each airport. You'll notice that after the name of each field, I then specify the data type for each field. So airport code and creation dates, those are stored as strings. The creation date would probably be stored as an RFC 3339 string so that we have our contract that is maintained between the client and the service as to the format of that string. The number of runways and takeoffs per hours, I put them in here as numbers. Now you could say integer, but when these go over the wire as JSON, JSON has the concept of number, and some programming languages do not even have the concept of integer, like JavaScript, for example. So by using number here instead of integer, I'm kind of making a nod to the idea that this is going to be language agnostic as the clients go and consume this information. My next piece of information that I recall about each field is whether that field is set by the client, which is true in the case of the airport code, the runways, and the takeoff per hours, or whether that field is set by the service when the resource is created or managed by the service. And then I have this mutability row. The mutability row I'll talk more about on the next slide, but I'm indicating here if a field is marked as create, that means that that field has to be specified at creation time. If the field is marked as read, that means the client never sets this field, but the client can only ever read this field from the service. If the field is marked as update, that means that the client is able to modify these even after creation time. So in this case, the airport code, once it is set in stone and can never be changed. But over the course of an airport's lifetime, they may add or remove runways from the airport, so we can update that number. And of course, the number of takeoffs per hour at that airport may change, hourly or daily there if it's an average. So that's why this information is easily updatable. So that's my definition of the collection and its schema, if you will. Now I have added one resource into this collection. The airport code is C, which is for Seattle Airport. The creation date I have in here 2020-09-01. The number of runways I have in here is 3, and the number of takeoffs per hour I have in here is 810. So now that you have a sense of this collection that we have up on the service, we're now going to look at the REST APIs to go and manipulate this collection and the resources within it. So the first operation we're going to look at is, let's say we wish to create a new airport resource in this collection for LAX, that's the Los Angeles airport. So in this example here, I'm doing a patch operation to the /airports, which is the name of the collection, and then /LAX, which is the name of the resource within the airports collection. Now, because when I execute this patch, that there is no resource in the collection called LAX, this is actually going to end up being a creation operation. And I am specifying in the JSON payload here that when I create the LAX airport, I also want to set the number of runways it has equal to 4. So when I execute this patch operation, we can see in my database table that resource number 2 is created. Its airport code is LAX. It has the creation date of 2020-07-27, and it has 4 runways on it. And the takeoffs per hour is currently left blank because we never set that possible value. Now let's go and say we want to go and update this resource's information. So to do that, I'm using patch again. I'm going to patch to the same URL I did before, so I'm modifying the LAX airport in the airports collection. And now I'm specifying the takeoffs per hour field with a value of 1500. So since the LAX airport exists in this case, it's going to be an update operation that's being performed. And because we're only specifying takeoffs per hour, all the other fields are going to be untouched by this patch operation. Only the takeoffs per hour field will be modified and have a value set of 1500. So when I execute this, you'll see in the table, the takeoffs per hour changes to 1500. All right, so now I want to do a get operation to go and retrieve this information. So I'll do a get to the airport's LAX resource. And when I do that get operation, which has nothing in its request body, but when the response comes back, the response will come back with the code of LAX, the creation date, the number of runways, the takeoffs per hour, and so on. Now, another operation you might perform is a list operation to list all of the airports. In this case, it's still a get operation, but it's to the /airports collection and not to a specific resource within the airports collection. And we have a standard pattern that we use in Azure for returning collections like this. We end up returning a JSON payload, JSON object, that has a value field in it. And the value of the value field is an array of JSON objects. And each of those JSON objects represents the resource itself. So here you can see the first element in the array is a code of Seattle, and then I have ... here because I didn't have enough space to put all the additional fields, but those would be there as well. And then I have a code for LAX, and then ... for its additional fields, and if there were more resources in the collection, then we would have more objects in that array. Note, by the way, that it's pretty important that even though the name of the resource is LAX or SEA, you'll notice that there's a code or sometimes an ID property that's inside the JSON payload itself. This is very handy for multiple reasons. The one reason is for a collection like this. If we didn't put the code in here, then you would have all these values coming back, but you wouldn't know which airport they identify. So it's very useful to put that code in there. Also, sometimes people will put in here the URLs. So instead of just SEA, it could actually be /airports/SEA. Then a client could go and then do an update or patch operation to that URL and wouldn't have to know that it's in the airports collection again. Another reason why it's useful to have the code in here is because when you model a data structure in a programming language that has an airport resource in it, you're going to put fields in that data structure. And when the payload comes back over the wire into the client, you'll deserialize that payload into the structure. Well, if you don't have the code coming over, then the structure has the information, but only the caller knows to what airport that information is to. If you now take that structure on the client and you pass it around throughout your application code, there's no way for the other code to know which airport these other fields apply to. So it's very handy to put the ID of the resource inside the data structure itself. That's very useful for debugging and for other pieces of code to be able to manipulate this resource in the future. Later in the course, I'll talk about collection classes and how each of these gets really returns a subset of the collection, because the collection could have millions or maybe even billions of records in it, and we just can't have a service spending all of its time returning billions of records for a single client. That's not a good use of our COGS, or cost of goods, running the service. So services tend to return segments or portions of a collection with a next link field. And then when the client has processed that subset of the collection, it then does a get to the next link to go and get the next subset. And for the last subset or segment of the collection, the next link field would be missing. And that's how a client would know it had completed iterating over the entire collection. Finally, this operation here shows how to delete an airport resource. In this case, I'm deleting LAX. So I do a delete HTTP method against the airport's collection and the LAX resource within that collection. And when I execute this, that row in the table now gets destroyed and it is completely gone. Now I'd like to talk a bit more about the JSON resource schema and field mutability. For any given URL path to a resource, you'll define a JSON schema. That will get turned into some data type or structure in a client library that a customer might be using. And we want that data structure to be the same one that's used for all of the HTTP methods that talk to this kind of resource. That is patch, put, get, delete, and even when getting the items of a collection. In other words, in our client library, we want to define one SDK type or data structure, and we want it to be used as the output when doing a get operation, and we want it to be used as the input when doing a patch or put operation. This allows the customer or the client code to easily get something, modify some fields in it, and then go and patch the thing right back. For a patch or put request, it's common that a subset of the fields will be sent to the service. So as you're designing your resource schema, you want to mentally associate with each field, whether it's a create field, an update field, or a read field. And based on this mental connection that you've made with the field, you need the service to have special behavior. So let's walk through those. If you have marked a field as create, that means that the service honors the field only when creating a brand new resource. You want to minimize the use of creation-only resources in your schema, because that means that once a customer has set it, they can never change it. So what customers tend to do is they tend to delete the resource and then recreate it from scratch in order to change the create-only field, and we don't want to force people to have to do that. We want people to just be able to modify whatever they can. It's very common, of course, for the key or the identity of something to be, of a resource to be created and never mutated after that. And that's, you want to make it so that's the only one, if possible, and no other fields are marked as creation. A field mutability of update means that the service honors the field when creating or when updating a resource. That means, of course, that the field can be changed over the lifetime of the resource, and customers really like this when this is possible. And then read means that when the read field is sent to the service, then the service should fail the request, because this is a field that the service owns control of. And it sees that the client is trying to change the value of this field, and the clients are not allowed to do that. We don't want to silently fail on the server typically. We typically want to fail and let the client know it failed. That way the client knows that this value is not accepted by the service. We wouldn't want the client to think, oh, I'm trying to change this creation date of the airport, for example, and it gets back a 200 saying okay, when in fact it didn't change the creation date at all. And so read-only fields are typically returned in a response and are typically not sent to the server back in a request. Now let's talk about how a service goes about processing a patch or put request. When a patch or put request comes into the service, it would walk through these tests that I show in the table on this slide. The first thing is, if this is a patch or put request, the service would make sure that any JSON field in the request payload, its name or its value. If it's not known or not valid, then the service would immediately return a 422 unprocessable request because the JSON doesn't make any sense to the service, so it should fail immediately. If we make it past that test, then the service should check to see if there's any read field that has been passed. Clients are not allowed to set read fields, and so if the service sees one of these, it should again immediately fail the request with a 422 unprocessable entity. That lets the client know that you tried to change something you're not allowed to change, and fail the request immediately. If we make it past those first two tests, then what happens next depends on whether the service sees that this resource does not exist and it has to create it, or whether it already exists and it's going to update it. Let's talk about the case when the resource doesn't exist first. In this case, regardless of whether it's a patch or a put, the service would check to see if there's any mandatory create or update fields that are missing from the JSON payload. So if there's some field that's required to create a resource but it's not there, then again the service would return a 422 unprocessable entity back to the client. If we make it past that test, then finally everything is good. The service can go and actually create the resource, setting any of its fields based on what was passed in create or update fields to the service, and then ultimately the service would return a 201 created back to the client, so the client knows everything was successful and the resource now exists up on the service. Now let's talk about the case where the request comes into the server. It did the first two tests successfully, but now it has found out that the resource already exists. In this case, the service is not going to create it, it's going to update what is already there. What happens next depends on whether it's a patch or a put operation. If it's a patch operation, the service would check if there's any create fields that were passed in the client, whether they currently match or do not match the field that's in the resource itself. If the fields do not match, so what was sent by the client does not match what's in the service, then the service should return a 309 conflict indicating to the client that you're trying to change something that you're not allowed to change. However, if the field is a create field that's being sent over the wire and its value matches the current value, then we want to consider that success case. And the reason is because this allows retries to happen. All right, a client might try to do a patch operation to update a resource, and maybe the client times out, and so it retries the patch operation again. Well, we want it to be successful ultimately with doing this, and so if it's trying to create or pass create values in, we want to make sure that if they're the same value, so it really wouldn't change it anyway, we're just going to let it go and say it's okay. Then if we make it past that test, we're all set to update the resource using this patch operation, and so the service should go and update the resources fields using the update fields that came in from the client, and then ultimately the service would return a 200 OK back to the client indicating success. If the client is doing a put operation instead of a patch, then the service would then check the put to make sure that any mandatory create and update fields are missing, and if any of them are missing, then the service would return a 422 unprocessable entity. You have to remember a put, the concept there is a wholesale replacement. It's kind of the equivalent of doing a delete followed by a create, or a delete followed by a put. So for puts, the client is always wholesale replacing the resource that's up there with whatever's in the put. So if a resource requires certain things like create and update fields, then the service has to make sure that they're passed in the put request in order for this to succeed. If all the mandatory fields are there, then the service would go and overwrite the resource entirely, right? Because that's what I said, put is a wholesale replacement. So the service would overwrite the resource that's there entirely using the new create and update fields that were passed by the client. And then the service would return a 200 OK back to the client, indicating that this resource has been put successfully up to the server.